Let's begin with part 3, inferences for the difference of two proportions. So far we've focused on making inferences about a single proportion or mean. So you gather a random sample, you calculate either a proportion or mean from that sample, and you want to use that information to generalize to some population that you haven't observed. But often we're also interested in saying something about differences in population proportions in two different groups. For example, you might say, what is the percentage or proportion of men versus women who support single-payer health care in the United States? What is the proportion of people with a college degree versus those without a college degree who are living in poverty? Or, to cite another example, is there a difference in the proportion of patients who survive a heart attack between those who exercise regularly and those who do not? In each of these examples, we're interested in comparing two proportions in a population based on a sample of data. So the goal here is that we have two population proportions, which we denote by P1 and P2. So these are proportions in the population, and our goal is to make an inference about the difference between these two proportions. So we want to make an inference about P1 minus P2. The important point here is that we're dealing with a single number. P1 minus P2, that's one number. Right? That simplifies our approach quite a bit, actually, because the point estimate for a difference of two proportions is simply the difference between the two sample proportions. We just take p hat for one group minus p hat for another group. This is our best guess of the difference in the population proportions, P1 minus P2. Then what we can do is we can treat this difference of sample proportions as a point estimate, as a single number for our best guess, without additional information, for that difference in the population. So the next goal is to construct a confidence interval for the difference of two sample proportions. As a general rule, if the number of successes and failures is greater than 5 for each proportion, then the sampling distribution of p hat minus p hat for the two groups is approximately normal, and we can use the z-test. So we can use a z-interval for a difference of two proportions as long as that condition holds. So for the difference of two proportions for two independent samples, it's calculated in this way. You take your point estimate for the difference of proportions in the populations, plus or minus z alpha divided by 2 times the standard error. So you take p hat subscript 1 minus p hat subscript 2. That's a single number, plus or minus z alpha divided by 2 times the standard error. Just as same as before. You have a point estimate plus or minus a margin of error. The thing is, the standard error is calculated in a slightly different way because we have two groups. Right? The idea is we have two sorts of samples going on. But intuitively, all the standard error is you take sort of p hat, you take p subscript 1 times 1 minus p subscript 1 divided by the sample size of that first group, plus p subscript 2 times 1 minus p subscript 2 divided by the sample size of that second group. You add those two together, and then you take the square root. Intuitively, it's kind of like adding the standard error in a way of two different samples. It's not quite the same, but it's pretty close. The idea is that each sample size is used to calculate the standard error, and then we will use these two proportions. Now, the thing is, we don't observe these two proportions in the population. We don't observe P1 or P2, so we will typically use P hat 1 and P hat 2 as estimates for P1 and P2 when we calculate the standard error so that we can calculate the z-interval for a difference of two proportions. Intuitively, it's the same as before. You have a single number, a point estimate. In this case, it's just a difference. And then you add and subtract the margin of error. And the standard error is pretty much the same as before, except we have to add in the fact that we're taking into account the sort of variation from two sets of groups. And with that, we're going to go through a few examples of calculating a z-interval when we have two proportions.